Hello, my name is Rebecca Connelly. I am a high school chemistry teacher and I have earned a BS in chemistry, an MS in science education, and an EDD in STEM. I am also the curriculum designer of the Arconic Materials Explorers activities. The Arconic Materials Explorers activities, as well as additional resources, are available on the Materials Explorers website at www.materials-explorers.org. The activities include topics such as measurement and scale, data collection, chemical and physical properties, and states of matter. This video will walk you through a typical classroom visit, as well as a brief overview of the newest additions to the Materials Explorers suite of activities. The volunteer visit helps students make connections between the content they are learning in class and the real world. Volunteers bring to life content that students often have difficulty conceptualizing. Teachers hope that volunteers can share their expertise with the students and help them understand how the knowledge they are gaining in class can be applied to a variety of situations. A typical volunteer visit consists of a 15 to 20-minute presentation from the volunteer, followed by students engaging in one of the activities. Prior to bringing a volunteer into my chemistry classroom, the volunteer and I exchanged several emails. I provided him with a brief background of my students, notified him of the topic I wanted him to present, reviewed my classroom expectations, and informed him of security procedures, including necessary clearances required to enter the building. The topic I elected was states of matter because students were about to learn about intermolecular forces and how materials can change from one state to another depending on the strength of the intermolecular forces between molecules. The volunteer began his presentation by providing a brief overview of material science and physical and chemical changes. He then proceeded to share an engaging presentation with the students that included many graphics and questions. He discussed the topic by relating it to examples from his own workplace, in this case, the process of producing aluminum sheets for Cadillacs. He then talked about career opportunities in research and explained his personal career pathway. The volunteer's presentation was concise and engaging. His presentation lasted between 15 and 20 minutes, which allowed for students to engage in the states of matter activity. Students worked in small groups to complete the activity as the volunteer circulated around the room to check on the students and engage them in discussion. Feedback regarding the presentation was collected after students completed the activity. After the visit, students expressed that they found the volunteer's presentation to be interesting and relatable. They mentioned that they loved how he related a concept they were familiar with to the real world. Overall, the experience was very positive and thoroughly engaging for the students. Next, I would like to provide a brief overview of the newest Materials Explorers topic areas funded through a grant from the Arconic Foundation. The measurement and scale activity requires students to investigate the impact of hail on aluminum car hoods. Students are tasked with developing their own procedure to simulate hail using ball bearings and various forms of aluminum, such as cookie sheets, pie plates, or foil. Students must apply significant figures to their measurements and calculations before drawing conclusions and preparing a report for an insurance agency. The extension activity takes a broader look at measurement by introducing students to certified reference materials and the controversy over how to measure a kilogram. It requires students to investigate the international system of units and the importance of accurate measurements. A volunteer in the classroom could not only discuss the importance of testing materials for quality assurance, but could extend the activity by encouraging students to consider how hail falling from various heights or with different velocities may impact the results. The chemical and physical properties activity introduces students to the concepts of corrosion, alloys, and surface engineering. Students investigate corrosion rates by testing various substances with different pH values on aluminum foil and steel paper clips. The analysis questions connect the activity to the importance of selecting the right material or using protective coatings. This activity must take place over the course of a few days for students to see the corrosion. A volunteer in the classroom, however, could incorporate a demonstration into his or her presentation that allow students to quickly see corrosion. The volunteer could quickly demonstrate corrosion simply by placing a paperclip into a beaker and adding some 0.1 molar copper 2 chloride. As you can see, the drops where the copper 2 chloride hit directly on the paperclip caused corrosion almost immediately. You can start to see parts of the paperclip flake off, and you also notice a color change, which is a sign of a chemical reaction. So the paperclip is changing from sort of a gray or silver color to a black color. So this happens almost immediately. A second demonstration that the volunteer could conduct is using similar materials, except I'm going to replace the paperclip with a piece of aluminum foil. Now you can already start to notice that unlike the paperclip, the aluminum foil doesn't quite experience a color change as soon as I add the copper 2 chloride. So this reaction is going to take a little bit longer, but if we start to swirl the aluminum foil and the copper 2 chloride, start to see a little excuse me, you can start to see a little bit on the edges how a color change is beginning, and it almost looks kind of red or dark brown, whereas the foil that we put in was pretty lustrous and silver. So what's happening in this reaction is actually a single replacement reaction where the copper is being replaced by the aluminum. So the copper ends up on what the foil was, and we end up with aluminum chloride as our aqueous solution. So again, this reaction happens more slowly, but you can see that what was the foil started to deteriorate, and there's some flakes of copper floating in there, and the copper is now on the aluminum foil because it was replaced by the aluminum. The demonstrations that you just witnessed will pique students' interest in corrosion since they can see the transformation right before their eyes. The volunteer could then relate the demonstration to corrosion that occurs on vehicles due to the exposure to salt in winter. The extension activity looks at a historic example of the cracks that formed on the Liberty ships in World War II to show students how understanding a material's physical properties is critical to a successful and safe product. The article highlights the role of scientist Constance Tipper and presents a strong female role model who founded an entire field of engineering. The States of Matter activity introduces students to phase changes and intermolecular forces. Students begin with ice water and add heat until the water boils. Students record temperatures at various intervals, then generate a heating curve and answer various questions about the phase changes that occur. The extension activity also requires students to generate a heating curve. The materials in the extension activity, however, are tin and bismuth. Since many schools may not have access to thermocouples, which are needed to record temperature in the extension activity due to the high melting points of tin and bismuth, this activity would serve as a great demonstration for the volunteer to conduct. If the volunteer does not have access to thermocouples, tin, and bismuth, another phase change activity that could be demonstrated is the sublimation of dry ice. The volunteer could talk about why dry ice is used to pack and transport items. The volunteer could also show students the triple point of dry ice. The volunteer could also show students the triple point of dry ice, where solid, liquid, and gaseous carbon dioxide coexist. The data collection and graphing activity and the extension activity introduce students to the scientific method. Students analyze temperature, yield strength, and Young's modulus data from an aerospace component. Students are tasked with graphing and interpreting the data to answer questions about which alloy would be most appropriate to compose the various parts of a jet engine. A volunteer could walk students through the type of data they collect in their job and discuss the various lenses through which they analyze the data. Volunteers may also want to discuss various types of data collection, such as data collected from consumers that drives product innovation. The final activity is a capstone activity. The capstone activity requires students to apply their knowledge of material selection and the scientific method to conceptualize and design their own product. Students will look around their home, school, or greater community and identify a problem that can be solved by designing either a completely new product or improving a pre-existing design. Students will also select the best materials for creating their product after determining the 3 properties that would be most important to them, such as appearance, cost, corrosion resistance, etc. Since the capstone is the culmination of all the Materials Explorers activities, a volunteer visit may be most effective after students complete the activity. The volunteer may want to suggest to the teacher that students set up their posters in a symposium fashion where the volunteer could circulate around the room and listen to students' presentations and provide feedback. The volunteer may also want to gear his or her presentation towards the engineering design process and talk about how problems drive the entire process. We hope this video encourages you to consider volunteering. If you have any additional questions, please contact materials-explorers@tms.org. Thank you.